Okay, so this will be the beginning of our next guided project, which is going to cover Minesweeper. I'm going to put that there. And so we need to sort of go over how we want to represent the game in memory and think about how the computer can do everything that needs to happen in the game and be able to figure out what that it needs to do based on the state of the game. And so that's kind of what we'll go over here. So Minesweeper is a single player game. There'll be one player. We don't have to keep track of which player's turn it is, since it's always the same player's turn. So we don't need a variable for the player. We do, however, have to record the state of the game, because as you play the game, there are things underneath. It's a grid-based game, and basically there are things underneath the grids. Underneath each cell is basically covered, and you play the game by uncovering cells, and when you uncover them, you either reveal that there is a bomb there and you lose, you hit the mine, or you reveal information about adjacent cells. And essentially the information is how many of these cells adjacent to that one contain a bomb in them. And so the game is basically a sort of arithmetic spatial type game where you try to figure out where the bombs must be based on the information that you can see, and every click reveals more information, but there's a little bit of risk in that you may not be calculating properly. So the way now there's many ways that you can always create a game or model a game. So far we haven't talked about objects yet, or in JavaScript, which is one method that you could use to model this. We'll get into those soon, and I think you'll see that those can be very useful. So the way I'm going to show you to make Minesweeper, I was about to say Minecraft, the way that you can make Minesweeper is, this is just one way. There's plenty of other ways. If you look up online, Minesweeper, JavaScript, I'm sure there's lots of examples of how to make this game. I'm sure a lot of them are much more polished than what I'm going to make here. What I'm trying to do here is limit us to just the structures and the patterns that we've been going over so far, and that way you can hopefully follow it. So the way I'm going to represent it, which is a choice, and probably other examples will model it differently, is once again, like the tic-tac-toe example, I'm going to model this as a two-dimensional array. So a grid, typically you need something like that, some sort of grid representation. So I'm going to use nested arrays. So each row will be an array, and the field that you play on, the thing that's underneath the cell covers, that the state of the game, that will be an array itself, with inside of it several arrays, where each internal array is a row of numbers, a sequence of numbers, And you have, in this example that I have up here, 1, 2, 3, 4, 5, 6. 6 rows. So I'm going to have an array, and inside of that I'm going to have 6 other arrays. Inside of each of those 6 arrays I'm going to have 6 numbers. And you can see in my example the numbers that I'm going to have in there represent either basically what's in that cell. Is there a bomb, which I'm going to represent with a -1? Is there, or it's going to have another number which represents how many bombs are adjacent to that cell. So you can see in my example, and I'm going to color code them too, kind of like how I have shown here. If the cell is empty, actually I'm not going to show the zeros. I'm probably going to, let's see, those won't even have indicators there. If there's no adjacent mines, they'll just kind of be empty. I need some sort of graphic to represent a cover so that you can tell which cells have been revealed and which cells haven't. I'm mostly going to do that with backgrounds, so if you can see a cell, or if it's covered still, you haven't revealed it, it's going to look lighter with some edge effects that make it look like a little button top. And when you click it, it's just going to be a flat, darker gray so that it looks like it has been depressed, like it's been pushed down. And then the number will be revealed. So even if there isn't a number there, you know it's like there's a 0. You know if it's been revealed or not based on the color of the cell. It'll just be darker, basically, if you've revealed it. So that's how we're going to go. The state of the game is going to be stored in 2 variables. They are both going to be nested arrays. They're going to have the same dimensions. So in my case, in this example, it's a 6x6 on the left and it's a 6x6 on the right. And the idea here is that underneath it all, there is the what's on the board, what I'm calling the field of mines, the mine field. There are mines, and there is information about how many mines are adjacent to each cell. That is static, so that doesn't change. When you click things, it doesn't change for the most part. What happens is you reveal things. So I need to keep track not only of what's in the cell, but whether or not the cell is revealed, whether or not I've exposed what's underneath that cover for that cell. So I need a second array, a second grid, so I have information about every cell. On the left, I have information about what's adjacent to every cell, or what's in it. And on the right, this mask object, this mask structure is going to have information per cell in the form of a 1 or a 0, which basically indicates what the player can see. And if it's a 0, that means that that cell is not revealed, so it is still covered. And when it becomes a 1, then the game will know that the player has revealed that cell, and now they should be shown the number underneath as for what's in that cell. So on the left is something that for the most part does not change, and on the right the game is to basically unmask things, and when you see more, it informs the player of what they should reveal next. So really the player is mostly affecting the mask. They're not really affecting the field when they click. They're just revealing things. So let's say the player clicks a cell, let's say this cell right here. And the way the algorithm will work is that when you click something, it will, whenever you reveal a cell, there's a couple things that will happen. The first cell that you click, you will reveal, if you click that cell, it will reveal all the adjacent cells. So there are 8 adjacent cells. those will be revealed. On top of that, if a cell that is to be revealed is empty, like here, it will reveal all the adjacent cells to that cell as well. So if there's a 0 for this cell, all of its neighbors get revealed too. And so these 4 cells will reveal their neighbors when I click this cell. These 4 will not, because they have numbers, so they won't be revealed in themselves, but these 4 will reveal themselves and reveal their neighbors, their adjacent cells. And then if I get more zeros, more empty cells, their neighbors will get revealed. And so basically when you click, it reveals all these zeros and then the edge of numbers around that set of zeros. So that's what will get revealed. So I have another graphic. Let me get rid of these zeros so that it looks smoother, maybe. Whoops. Okay. I gotta click something. Okay. Why did it do that? Okay. Well, still, that's okay. So this was the state before. And then if you clicked here on the grid, it turns into this. So when I click this cell, I highlight it in yellow on the mask so you can see where I clicked, and all of these cells flip to revealed. So I pretty much get everything that's around where I clicked, and then where there are zeros, I get everything around those, and the algorithm stops once it reaches a number. But as long as there's an empty cell, it keeps going. So when my first click would reveal this whole lower left part of the box. Actually, it was almost half of the box. So that's how the game plays. And then I can choose another cell. Maybe I'll decide to click here, and it will show the neighbors, but not if it's a bomb. It won't show the bombs, but otherwise it will show the neighbors. And if there's no empty cells, no zeros in the field, then the algorithm will just stop after the adjacent cells that you show. So that's the game. So again, we're going to represent it with 2 nested arrays. One's for the information, one's for the field. And we reveal to the player based on what the mask is. We reveal the field based on whatever the mask says to reveal, and we hide whatever the mask says to hide. So that's how we're going to play the game. One thing to note, however, I did ask some people who play Minesweeper a lot, and according to them, your first click is not a bomb. So you get a freebie, I guess. And it sounds like your first click is always a 0. I'm not sure about that. We will mess with that later, but that's a slight complication. So what I was saying was that we will have the field, and it will be determined and set and unchanging, and what the player does is basically clicks and reveals things by editing the mask. The one caveat is that the very first click, the board is not established. The board gets established. We populate the board, the field, upon your first click. So because I don't want you to accidentally click a bomb on your first go, so basically we don't figure out what's on the field until your first click, and then we make sure that whatever you clicked is not a bomb by placing bombs after you click avoiding where you clicked. Maybe avoiding all the cells around you as well. So we'll make it robust enough where you can affect that. So maybe you could click a 1. Maybe it's always a 0 wherever you click first. We'll make it so that depending on how you want your game to be, you can make that choice. I'm probably going to make it where you could click a 1. Like, you don't have to be in an empty area. But we'll make it so that that's something you can toggle on and off. So the first click's a little different. With the first click, you trigger the creation of the field. And then after that, and then the mask gets determined. So the idea would be that there's nothing on either board. And then when I click, it fills in the boards, both boards. But then after that, the field is finished. And all you're doing after that is, with your clicking, is changing the mask. So the first click is different than every other click. Every other click, you only affect the mask. The first click creates the field. But after that, the field is done. There's no more editing the field after the first click. So that's how the game is going to be. That's how we're going to build it. So I hope that makes some sense, and I'll see you in the next video.